Okay, lana stau solve my problems. So actually, it's one problem, but one problem at a time. This is calculus. Calculus is not that hard. It is not hard at all. It just needs you to pay attention to the rules. Actually, for your case here, the rule is simple. You will see. Okay. Now we're continuing with elementary calculus, the derivative and the limit. So now there is an algorithm. So an algorithm is a set of rules, but lama rules lawa about Bali in English, like you should not steal or you should not rob or something. No, this rule it's written in what is called an algorithm. It's a mathematical form. So in this rule, the thing that you have to pay attention to would see which variable is which, and I will show you which variable is which here. But here I wrote it down that you should always write down this algorithm until you memorize it, until you can do without it. Because this is a set of my rules it's okay, did I do n minus 1? Did I do n times x? And so let's dive in. The first thing that we're going to do is a problem, and this problem I did it in two ways. The one way is the limit theorem, and then the other way is the derivative. You will see the answers are the same. So here they're saying find the gradient of the slope using the limit and the derivative method. So usually ku-exam yakho, they will give you something like this, and then they say find the gradient. They won't tell you use the derivative method or use the limit method. And whichever method you use, so long as you write it down and they can see what you did, I think you'll get maximum points. So now let's dive in. So the equation of the limit, its limit as h approaches 0, f of x plus h minus f of x divided by h. So you should be familiar with that. And so now when you are trying to get the gradient over there, the gradient, the function is x squared. The function f of x equals to x squared. And then the point at which you're taking the gradient is x equals to 6. So we use that 6 over here when we say, okay, limit as h approaches 0, f of, we use that 6 plus h minus f of, meaning that everywhere where there is x over here, you are going to use 6, supplement it for 6. So get that. So you leave the h as they are. Leave them alone for now. Okay. The f lona is just to tell us that, okay, this is a function. Function of 6 is a function of 6 plus h. So in that way, now, where there is 6, anywhere where there is 6, because our function over here is x squared. So f of x now, we would say this thing over here, this 6, wherever 6 is the x. So now our f of x, we supplement it for 6 plus h. Then we square it because over here it is squared. I don't know if I'm making any sense or I'm just talking. Okay, now f of 6, that's where it's going to be squared again. So all divided by 8. And so now so figure like the step place. what I did myself, I was like, okay, well, let's solve that first. And then you say 6 plus h times 6 plus h, because that is what 6 plus h squared is, right? So 6 times 6, it's 36. And then 6 times h, 6h, and then 6 times h is h, and then that will be plus 12h. Then h times h, it's h squared. So all the signs are the same over here, so it's positive. So you take that, you put it over here. Now, that 36 plus 12h plus h squared. But remember that 6 squared is 36, and then that is minus. So this 36 over here would subtract that 36 over there. So what we are left with now is 12h plus h squared divided by h. So I took that out again and said 12h plus h squared divided by h. This you can make it into 2, because this term over here, h squared, should be divided by h, and this 12h again should be divided by h. So basically you are not introducing another h, as in like double h bar over by 2. No, it's still the same h. It's just it divide a large term leli, it divide the large term leli. So to make it easy, I put a plus sign here. And so now what will happen is that 12h divided by h, labo h bayakhanselana lapha, and then you are left with 12. And then h squared divided by h, lo h lona ubang 0 or ubang 1, now umkhansela lana, and then uta la ukhansela h lo 1 la, and then kusala h lo 1 la. Okay, so now we have 12 plus h. So now we're taking the limit. Now is the time to take the limit, because everything else that we did over there was to set it up. If you take the limit from over here, you're not going to get the correct answer, because everything over here will be divided by 0. If you take like this 0 and put it to h over here and put it to h over here, you can't have everything being divided by 0. So when you put the h la, it will be like the whole thing is divided by 0, which is incorrect. But now, when we're here, 12 plus h like this, there is no dividing by 0. And let's establish 2. You had to come to this, because let's establish now, tata lelo kuza le limit, faka lo 0 la, ufaka la. Still, you will be dividing by 0, so you haven't gotten rid of lo 0 la. So, the limit lako nitoba njani nitoba wrong. But now that we are here, you can take the limit now and say take this 0 and put it over there, and then it will be 12 plus 0, which would be 12. So the answer is 12 la. This is the limit method that we used over there. Okay, now let's come to the easy method. It is easy method. This is the gist of calculus. That is where you will see with the calculus is easy. So we're saying, okay, taking the derivative of f of x as with respect to x, derivative of f of x with respect to x, and then f of x way to equals to x squared, so it's a derivative of x squared over dx. Now I showed you this algorithm over there. So that algorithm over here, the first thing that you want to do before you take the derivative, find out which one is n. And then when you find the n, and then your job is going to be easy, because right now n way to 2 la, because that's the n over here, that's the square, that's our n over there. So if bekung x la, dx instead of x squared, well, what you're going to do, n wakho bekutoba 1 because usually 1 asimbhali. But now our n is 2 because we're at the second power of our exponents. Now, you take that exponent, you put it over here in front of the x, right? And then when you put it in front of the x, you take that 2 again, you minus 1. That is what that algorithm is saying that the exponent should be put in the front and the exponent should minus 1 over here. So whatever you get over here, it stays over there, you will see. So 2x to the power 2 minus 1. Okay, and then 2 minus 1 is 1. The 2x lona uyahlala la. X to the power 1 because 2 minus 1 is bani, is 1. So the answer yethu kuba ngubani equals to 2x. But now remember, we haven't done anything with the x equals to 2. So what I was saying is that actually this f prime of 6, because this 2x over here, it's no longer like f of x, it's f prime of x. So now we want the f prime of 6. F prime of 6 would be 2 times log 6 because it's 2x. 2 times 6 equals to 12. That's the same answer we got over here. And that's the same answer we got over here. And this one, now, we had fewer steps. And that is why I always prefer, if you were taking your exam, if they didn't say that to use the limit theorem, you use this one over here, because the shorter your steps, the less likely you're going to make mistakes. When my steps are amaning, so it's very much easy to make a mistake. And then a mistake that will cost you maybe a few points. But this one is easy to get into. But in this one, get in the habit of writing the locus, the algorithm, which is n x to the power n minus 1. So n wakho is the exponent. If it's x3, n equals to 3. If it's x4, n equals to 4. If it's x1000, n wakho equals to 1000, and so forth and so forth. But there's one thing that I should show you. If you have there is another one that say 1 over x. Now, I have dealt with this locus at the time I was teaching my locus and my exponents and radicals, but I know that you might have forgotten. So 1 over x equals to x to the power negative 1. So if they say, give us a derivative, let's say f of x equals to 1 over x, and then find f prime of x. So what you do, you take this and then you make it into, you say it's equals to x to the minus 1. And then n wakho lana kutoba ngubani minus 1. And so this will toba na minus 1 in front times x to the power minus 1 minus 1. Okay? And so uba na negative x equals to negative x to the power negative 2. And then if your answer yakho is so, you are not finished. because you have to say it's negative 1 over x squared. You always have to neutralize ilokhuza exponent yakho by taking it down. And when it goes down, it figure langa phansi iba njani, iba positive. Don't forget the negative sign over here. All right. Well, now we'll try to make an example that will force me within ukukhombisa ukuthi if something like this, if they give you something but sithola derivative of 1 over x or 2 over x or 4 over x, because I saw one of the examples lago, actually it was a problem that they asked you to solve in one of the previous metric papers. Okay.